Hey guys, so this is number 2 for 2014 final, and it's essentially another stack pointer question. So the one thing that you have to know about this one is that there's no push or pull instructions inside of the stack pointer in this question. So where do we find what instruction actually affects the stack content? So the one instruction that actually affects the stack content is software interrupts, SWI, and they even give you a little hint here. It says, "Note, refer to the description of SWI instruction in the instruction set." So I printed out the instruction set over here, and so this is SWI here, and SWI says that it goes from SP minus 2 from the stack pointer, and then it says RTNL. Oh, sorry, let me just get this a little closer for you. Zoom in on that. So it says RTNH and RTNL goes into the memory of the stack pointer, and then to the memory of the stack pointer plus 1. And then it goes, the next one is SP minus 2 again, and then SP. And then it goes YH to YL, and then goes into the memory of SP plus 1. So what does that mean? Well, when it says SP minus 2, what it's actually doing, it's actually reserving 2 spots above the SP. So when it does the first one, it was SP minus 2, so it goes SP minus 2, so it goes up to here, and then it goes, sorry, let me get a finer point. It goes up to here, and then it goes up to here, right? And these are empty boxes. It's just reserving it first, right? So you see SP, let's see, you see SP minus 2 here, and then it goes RTNH and RTNL. So remember, first in, first out system, the leftmost byte goes in first, so RTNL is going to go in first, right? So it reserves 2 spaces by doing SP minus 2, so it goes up by 2, so these are empty boxes, and then those empty boxes, it loads in whatever it was going to load, so RTNL and RTNH, so it goes in from low to the high. So that's why here, the first one is RTNL, and so what's the other one going to be? So we reserve 2 boxes first, RTNL went in, and then what's next? Again, we'll just look at this right here, and then it's going to be RTNL, it went in, and now it's going to be RTNH, right? So we're going to write RTNH. Okay, and then what's the next one? Just keep going down the list now, right? It's fairly simple. So SP minus 2, okay, go up by 2 boxes, and we're going to put in register Y now, the low register, the low of the register, the low byte, and the high byte. Okay, and we're going to put into SP and then SP plus 1. Okay, cool. So go back. So what did we load into Y here? So 48 and 67. So the leftmost byte goes in first, and then so it's 48 and then 67. Okay, so SP minus 2, reserve 2 of them, 1 and 2, and then in the first one we're going to put the leftmost byte, which is 48. So this one's going to be $48. This guy's going to be $67. Okay, so let's go back to the instruction set here now. Okay, so it's register X now, right? So okay, register X, cool. So let's put in register X. So load X with 45, 44, 45. So 45 is the leftmost byte. Again, we're going to do the same thing that we did with Y. Oh, that 8 looks atrocious. Let's fix that. There we go. Okay, and so going back to X, so the leftmost byte of X is 45, right? And then the one to the left of that, the high one, is 44. Okay, so X is done now. So let's go back to the instruction set and see again. So it says SP minus 2, and then goes loads B to A. Okay, and so remember that accumulator D is also A and B combined. So if I write it on a box here like this, this is A, this is B, and this is D. So the high portion of D is A, and the low portion of D is B. Okay, so load accumulator D with 34 and 33. Okay, so 34 is on the right side, and 33 is on the left side. Okay, so in the instruction, we're going to load A first and then B next, right? First in, first out system. So we're going to load B, which is $34, and then we're going to load A, which is $33. Okay, and so the last one we're going to load in is called the CCR, right? And so that's what tap does. Tap over here, it means transfer A into the CCR right, which is the code condition register. So the code condition register is this. So the code condition register is this, and it's a register in itself. It's called register H, and what it does is it helps us track a bunch of things, and when we do operations, these certain codes will react to which operation that we did, and then we use this as a reference to do a lot of like equivalencies and stuff like that. But for the sake of this question here, we're going to be loading A into CCR, right? So we're going to transfer accumulator A into CCR. So what was in accumulator? It's 33, right? So in CCR, we're going to load 33, okay? So it's 8 bits, so 33 in 8 bits, right? So grabbing my conversion chart, it's 0, 0, 1, 1, okay? So there's going to be 2 of those, okay? So inside of CCR, it's going to be 0, 0, 0, oops, sorry. It's going to be 0, 0, 1, 1, 0, 0, 1, 1, which is 3 and 3, into the CCR. Okay? So, let's see. The last instruction for the software interrupt is SP minus 1, so it's only reserving 1 byte for CCR. And what's the leftmost byte for CCR right now? It's 3. It's 33, right? So, we're going to load in 33. So, and the last one is 33 as well. Okay, alright, if you have any questions, please let me know. Shoot me a text or shoot me a message, and I'll try to get back to you as soon as possible.